Some questions require that you know the formula, and this formula is on your formula sheet. NPR equals n factorial over n minus r factorial. So if you get a question like A, it will require that you know that formula, and it has NP2. So if I plug that into the formula, I'd have n factorial over n minus 2 factorial equals 56. One of the things we're going to learn when simplifying factorials, we do so by using the definition and always expanding the bigger number. So the first question when you look at these two factorials is which is bigger, n or n minus 2? N is bigger. If you're ever wondering, you can plug in a number for n. Choose 8. Which bigger, 8 or 8 minus 2, which is 6? 8. So the number on the top, the n, is going to be bigger. So we start expanding it with factorial. It'll be n times by 1 less, which would be n minus 1, times by 1 less. And when we get to the factorial on the bottom, we can stop. Because once we have the same thing in our numerator and the same thing in our denominator, we can simplify. Notice the factorial sign is only on that last one. Again, with numbers, had I chosen 10 factorial over 8 factorial, and I expand the bigger one, well, 10 factorial is 10 times 9 times 8 all the way down to 1. But once I get to 8, instead of writing it all the way down to 1, I can just say 8 factorial. Because that would mean 8 times 7 times 6 all the way down to 1. And if I stopped at 8 factorial, because I have an 8 factorial in my denominator, things would simplify away. So the same thing happens in algebra. I go n minus 1, and when I get to n minus 2, since that's what's on the bottom, I stop with the factorial sign, and I can simplify. My equation then becomes n squared minus n equals 56. What kind of equation is this? A quadratic equation. How do we solve that? We make one side equal to 0. N and n minus 8 and plus 7. Now, for factorials, we can only have factorials. Our definition only worked when n was a positive number or 0. So we would have to then also go and say, this one's not possible. We can't have negative factorials. So the only answer is n equals 8. Question A is a very typical exam question. And in question A, they'll say, can you solve this algebraically? And what we just did was using the formula and using algebra to simplify it. Okay, question B is a non-typical exam question because the best strategy is a non-algebraic one, which for pre-calculus students makes them not feel very good. You guys have been trained throughout all of high school to be used to solving things algebraically, and when you have to do something kind of guess and check, kind of non-algebraically, you feel like you've cheated or done something wrong. And this is one of those questions. Remember when I made the connection that the permutations formula, that this second number represented the number of spaces. So if we're starting, and this was the first number. So if I had one space, is that equal to 20? No. So I add another space. Would that equal 20? Yes. So R is equal to 2. And it feels somewhat like we've done something wrong because we're kind of guessing and checking, but just using our understanding of how the permutations formula is related to the fundamental counting principle. Okay. Questions for this one? Just number 10.